Okay, good morning all. We're going to start a new topic today. It's called rates, rates of chemical reactions, which is topic 7. Okay, now you will have heard the word rate before, and it usually refers to the comparison of some change of something with time. It's almost always time. Okay, so a speed is a rate, meters per second, kilometers per hour. But there's lots of rates around us. You know, how much a continent moves in centimeters per year, for example. So you'll notice that all of those rates had the word per in the middle. So it's something changing per unit time. Okay? In chemistry, obviously, we measure amounts of stuff in grams, centimeter cubed if we're talking about gases, and moles. So it's going to be moles per second, or grams per minute, or centimeter cubed per second. Okay? So that kind of makes sense. That's what we do. Now, we have to know how to measure rates of reactions in the laboratory. The easiest way of doing it is if there's a gas produced in the reaction. We know of lots of reactions with gases produced, or we should. We will remind ourselves over the next few slides. Okay, so here we go. Method 1 is the volume of gas given off. And you have a reaction going on in the reaction vessel, in this case a conical flask, and it's producing a gas. This is called a gas syringe, and these little marks here are graduations on the syringe. So that would be 10 centimeter cubed, 20 centimeter cubed, 30 centimeter cubed, etc. Okay, you measure the amount of gas produced at fixed time intervals. So in this case, they've implied that it's every 3 seconds, 6 seconds, 9 seconds. Can be done. Volume of gas in the y-axis, so the volume of gas produced, and time is almost always, I'm going to say always in these cases, on the x-axis. Okay? The amount of gas evolved can be read from the gas syringe, equal time intervals, and plotted on the graph. There you go. It's all self-explanatory. Right? Another way of doing it in the lab, more typical at IGCSE, is to use a measuring cylinder. And did we do this? I think we did this at the beginning of the year. We measured some gas given off. So you turn the measuring cylinder upside down, full of water, put it in a trough. This is a trough. And then as the gas is produced, the measuring cylinder slowly fills up. You read off the amount of gas produced at fixed time intervals, and then you collect the data and you plot a graph. Great stuff. In this reaction, we've got magnesium ribbon with the dilute acid producing the gas. So which gas would be produced in this case? Have a think about it. Acid plus metal. It's going to give me salt plus hydrogen. Yes, you guessed it. Method 2. Now, sometimes the gas that's produced is heavy enough, it's got a big enough MR, relative molecular mass, so that you can measure the loss of mass of the reaction vessel. So you've got the reaction going on and you've got the gas escaping. We put some cotton wool in the neck of the conical flask here to stop spray loss, because these things, they kind of spit and spray. But the gas, in this case, it's carbon dioxide gas. The gas can escape through the cotton wool. So we put it on a balance. We start the reaction. We take an initial mass, and then we just read the mass off again, fixed time intervals, and we can plot a graph. And the graph this time, because the mass is going down, it looks like this. This is the characteristic curve. Mass of the flask in grams on the y-axis, and again time on the x-axis. Okay. In methods 1 and 2, what we've just looked at, you can, at any moment in time, you can see, or you can calculate even, how fast the reaction is going. It's given by the gradient of the graph. So the steeper the gradient, the faster the reaction. And the gradient, as the reaction takes place, obviously things start to get used up, the gradient starts to level off. If you look at the previous graph with the gas being collected, it starts to, instead of going down and leveling off, it goes up but levels off. Okay, so the gradient of the graph is going to be key. We're going to work out how to measure that in a few minutes.